So now I want to discuss some notation that I'm going to use frequently throughout these videos. And some of it is notation that you don't often see in high school geometry, so I want to make sure that, you know, it's clear what I mean when I use some of this notation. For one thing, since lines will be sets of points, then, you know, if this is line L, then L is equal to a set, and I use these curly braces at the ends to denote a set, right? And then inside of the curly braces I write down all of the things that are in the set. So this would express that L is the set of points P1, P2, so on, so that, you know, P1, P2 might be naming particular points that are in the set, that are in the line. So that's one piece of notation. Another thing is how I express that something is in a set. There's a standard notation that comes from set theory, a whole other branch of mathematics. I have videos on it, but they're, you know, advanced. But in any case, in set theory, when we want to say that something's in a set, we write this. Right, so this would be saying that P is in the set L, or P is in the line L. So this is just like an epsilon, or maybe I should write it a little bit cleaner there. So this is saying that P is in L. It's a little epsilon symbol, or you could call it the in symbol, or whatever you want to call it, but that's the symbol I will use. Now, I also often want to talk about the intersection of two lines, right? So if I have L and M, and these are both lines, then the way that I write the intersection of them is with this, you know, sort of cap symbol, sometimes called, or it's like a upward pointing horseshoe, whatever. But that's the intersection of two sets, and it's the set of all points that are common to both. So if I had a second line coming this way, and that's my line M, then maybe P2 is the unique point that is in both of them, right? So the intersection just is. In fact, we tend to still call it a set, because, you know, it's just kind of nicer, easier if we say that the intersection of two sets is a set. It just kind of works out better for general purposes. So here we would say that the intersection of L and M is equal to the set of P2. We could, you know, come up with other, you know, sorts of things, like, you know, maybe this region intersecting some other line would be the set of just these points, right? So, in any case, this is the notation that I use for sets, for set membership, for intersection, and that's probably enough for the set theory notation. I'll also say that I use this symbol for if-then. So, for instance, here's a relatively simple one. If circle A, that's how I'm going to denote circles, is with this little circle symbol. If A is a circle with radius let's say 2, then it has diameter 4. I'll just write that. And if I wanted to really condense this with my little arrow notation, I would say if A has radius 2, then it has diameter 4. So this is a very condensed way of writing it, and so I frequently use that, because if-then sentences come up all over the place in geometry, so I abbreviate it with that. Okay, now we're ready to get started stating the axioms.